everyone. We are the lab HGWarriors. I am Lana, this is 𝗍𝙗𝗫𝙘, and this is Jerome. I started programming when I was 7 years old. I participated in the RCAP CoSpace autonomous driving last year, where my team clinched the first place. After that, I went to represent Singapore and the lab RCAP CoSpace competition at Tsingtao.
I started programming at 9. I was in the same team as Lana that won first place locally and secured a spot internationally at Tsingtao. We hope that our friends and family can continue to encourage us in this competition.
I was also part of the same team as the other two for NRC. But unfortunately, due to unforeseen circumstances, I was not able to join them in China. I miss participating with them, and I'm thankful to be able to participate again with 𝗍𝙗 and Lana.
We are participating in the CoSpace Autonomous Driving Challenge under the U12 category. For this presentation, we'll be showing you our task, which is the maze map. For this map, we have to primarily use colors to correctly navigate our car from the start to the end. This is because all the turning points on the map have a differently colored floor. Thus, we decided to make use of the color sensor to turn correctly at each of the turning points. We will now show you the solution we have arrived at. The car will start by going straight all the way, ignoring the fog at the start. When it reaches the first break in the lines, the color sensor senses the purple flooring and instructs the robot to turn left. The robot then continues turning at the various points using the different colors in the map. The robot comes across a differently shaded green flooring along the way. To make sure the robot turns accurately, we use the time variable to control when it should turn left and when it should turn right. Finally, upon turning at the last point, the car drives straight to the end point.
We try another approach where we turn immediately at the fog at the start, as we deem that path to be shorter. However, after multiple tests, we realized that the path is unreliable as the robot might turn the wrong way after the first turn, as there is a huge gap without any lines. Luckily, we were working in parallel, having the safer route coded out on another laptop, so that no time was wasted. Using the infrared sensors to move the robot seamlessly, we list down all the possible combinations of the ports that will sense the line. This is to ensure that we all get possible cases of deviation away from the line. Each combination will then have a different wheel speed setting. For sharper turns, the difference between the two wheel speeds will be greater as compared to slight turns. This is to ensure the time taken for the car to realign itself is at a minimum. We test and check to see if the robot correctly adheres to the lines.
Which AI tools we use and why we chose them? We use ChatGPT. We chose ChatGPT because it's great for brainstorming ideas, solving problems, and generating pseudocode snippets. How AI help in solving specific problems or improving efficiency? Error checking help us proofread our project, report, and presentation notes, ensuring that they were free of spelling and grammar mistakes. Challenges we face while using AI and how we overcame them. Over-reliance on AI. At first, we relied too much on AI for answers without fully understanding the solutions. To overcome this, we made sure to ask ChatGPT to explain its answers step by step so we could learn and apply the concepts ourselves. Our AI contributed to our learning and teamwork. AI tools help us to learn new concepts such as how color recognition algorithms work and how to debug code effectively. ChatGPT's explanations make complex ideas easier to understand.